In this problem, it says the sum of the measures of the interior angles of one convex polygon is 36 times larger than the measure of one exterior angle of a second regular polygon with 4 more sides. We want to determine the number of diagonals in the first polygon. All right, so what we have is we have two quantities. So let's untangle this a little bit. Let's first talk about this. The sum of the measures of the interior angles of one convex polygon. Let's start right there. Let's say that we've got n sides here. So the rule is you take 180 times the number of sides minus 2. So that's this quantity right there. Now the second quantity is this, the measure of one exterior angle of a second regular polygon with 4 more sides. So this quantity is n plus 4 sides. And the way you find that, now the thing is it's regular. We need to know that it's regular here. We don't need to know that for the first one. And that is you take 360 divide by the number of sides. So that means we're going to divide by n plus 4. And so what this problem says is that this first quantity in blue is 36 times larger than the quantity in red. So that means if in order to work an equation, we need to make them equal. So to make them equal, what we have to do is we have to multiply this quantity by 36 in order to bring it up and make them equal. So we set 180 times n minus 2 equals 36 times 360 over n plus 4. So we'll take the n plus 4 quantity and multiply it over. So we have n minus 2 times n plus 4 equals 36 times 360. And what we'll do is we'll divide both sides by 180. So that's going to cancel this out to 2. So we're going to have n minus 2 times n plus 4 equals 36 times 2 is 72. Now in order to solve this quadratic, it has to be equal to 0. So we're going to have to expand this out. So this is going to be n squared plus 4n minus 2n minus 8 equals 72. We combine the middle n's, so we have n squared plus 2n minus 8 equals 72. And then we subtract the 72 over to the other side. N squared plus 2n minus 80 equals 0. So now the quadratic is equal to 0, we can factor this. So this is going to factor, so we don't need quadratic formula here. This will factor into n plus 10 and n minus 8. So that means n is either equal to negative 10 or n equals 8. So n stands for the number of sides. And in this case, we cannot have a negative number of sides. So we're going to work with that. However, that is not our answer. Because now it says determine the number of diagonals in the first polygon. So now we need to take this and say, with 8 sides, how many diagonals are there? And the rule for diagonals is you take the number of sides times n minus 3, because what you're doing is you're discounting the initial point, the vertex itself, and the 2 to either side, because those are sides. And then you divide it by 2, because there's going to be another diagonal from another vertex coming in that counts as the same one. So we have to divide it in half. So in this case, we have 8 times 8 minus 3 all over 2. So that's going to be 8 divided by 2 is 4. 8 minus 3 is 5. So that means we have 20. So there are the number of diagonals. And there's our answer. And we're done.